This is a video tutorial just looking at mixed model Anova. So mixed model Anova is just a type of Anova that mixes between subjects and within subjects variables. So you have multiple IVs here. In this case we'll have two, and each of those have multiple levels within them. Here we'll look at a study where we're looking at variables called gender, week 1, week 2, week 3, and week 4. Let's click on variable view to find out more about this study. So here we see that gender stands for the gender of a rat. So this is an animal study. And then values will tell us more about that. So looks like 1 is male and 2 is female here. Alright, so then we've got 4 weeks. And during this time we're tracking the anxiety score of the rat. Okay, so to run the mixed model Anova, what we'll do is we'll go to Analyze, General Linear Model, and then Repeated Measures. See, this repeated measures allows us to define the within subjects factors, but it'll also give us a space for the between subjects factor of gender. So let's start with the within subjects factor. This is the factor that goes across time. So let's call it week. Oops. And then we'll have 4 levels because we've got 4 weeks here. And if we click Define, we can move all 4 of those weeks over to the within subjects variable. And then we have a between subjects factor of gender. So let's move that over to the between subjects box. Then we can click on Options, and just like before, we'll move everything over. We'll compare our main effects using the Bonferroni post hoc. And then we'll click on Descriptive Stats and Estimates of Effect Size here. As always, we can always change the significance level to whatever we need it to be. We'll leave it for this example, and then at this point, we're all done. So let's click OK. Now let's take a look at our output. So here is the output for the mixed model Anova. So we now have within and between subjects effects, so we need to check both of these. So let's start with looking at the test of within subjects effects. Here we see that week does have a significant difference. We do have a main effect of week. So what this is telling us is that between weeks 1, 2, 3, and 4, anxiety scores do differ. So how you would report this is by saying F parenthesis 3 using error 228 close parenthesis equals 3.67. Your p-value is 0.013, and then you've got your eta squared of 0.05. You'd round that up for your APA write-up. And you'd also round your significant level, your p-value as well. When we look at the interaction of week and gender, we also see a significant difference here. So that means that the amount of change for those anxiety scores do differ based on the time and based on the gender of the rat. So we would report our F statistic just like we did before, noting our degrees of freedom, which would be 3 and 228, and then our F value, our significance level P of less than 0.001, and then our partial eta squared of about 0.13. We also see here our tests of between subjects effects. If we click on that, we see the red arrow moves down here. So I'm looking at this box. Gender does also have a significant difference. So overall, regardless of what week it is, we do see a difference between males and females in their anxiety scores. So we would report F parenthesis 1, 76 equals 94.88, comma P is less than 0.001, partial eta squared equals 0.56. Alright, so we've got a lot going on, so let's break down what each of these mean. So first of all, let's look at our between subjects effect here. Let's look at gender, and we'll go to the pairwise comparisons for the gender of the rat. So this is our post hoc Bonferroni test, and we're looking to see how males and females differ. So yes, we do see a significant difference between males and females in their anxiety scores. And if we scroll up just a little bit, we have the estimates here. So on average, males have an anxiety score of 10, females have an anxiety score of 4. So this suggests that males are more anxious than females in this study. So that's one conclusion that we can draw. Now let's take a look at week. We also know that their anxiety scores overall differed based on the week. So if we click on the pairwise comparisons for that and we scroll up a little bit, we see that we have these means and these standard errors for each week. And we see really only one significant difference in that week 2 and week 3 there seemed to be a significant difference. Specifically, between week 2 and 3, anxiety went down. So you can see here, we go from about an 8 to about a 6-ish, 7-ish overall across all of the animals. So all of the animals' anxiety went down between week 2 and week 3. So it's another conclusion that we can draw. And finally, we have the interaction of rat and week, rat, gender, and week. So if we scroll down to this box that shows us the interaction here, we get their means and their standard errors, but we don't have post hoc Bonferronis really to tell us what those are. So while we could graph these and see whether or not the error bars differ, we can also add this extra step. So this extra step of changing your output is not something that you'll do a lot for our purposes, but I'll just go ahead and show you how to do that in case you're curious. So to do that, we'll run the analysis again. So we'll go back to repeated measures in general linear model under analyze. I'll keep all this the same, so I'll click define. And all of my options should still be the same from what I left it as, but instead of clicking OK, I'll click paste here. And what I should get is called my syntax. So this is where you can change your output a little bit by entering different lines of code. So to look at how anxiety scores differed based on both gender and week, what I can do is type in the word compare after this line here and put in my first variable, so I'll put in gender, and then Bonferroni. What this stands for is adjustment, and then Bonferroni, and this is just telling SPSS what kind of post hoc we want. So I'll do the same thing, but I'll now start with week. So I'll take this whole line, copy it, paste it here, and then change this gender to week. And then I'll select everything and then press this green button to run the analysis again. So here we have two essentially identical analyses, so all of this information is going to match what this information is. The only difference now is that here, where I didn't have any more boxes underneath the interaction, I now have two boxes, one where we started off with gender and one where we started off with the week. So let's take a look at the post hocs for that. Let's start here with week and gender. So now we can have a breakdown for differences in gender based on the week. So we don't really see any significant differences in the first week, but in the second week we see that if we scroll up here, males seem to be more anxious than females at week 2. So if we look at week 2, males had an average of 11.976, females only had an average of about 4.568. So while there was no difference in week 1, we do see a difference in week 2. Then if we look at week 3, we see another difference. So week 3, males are at 10.17, females are at 1.97. So females are decreasing even more in comparison to males. And then if we look at the 4th week, we see the same trend happening where males had a higher anxiety score than females did at week 4. So the next box that we added in will basically show us that same information, but they're separating it out in a different direction. So you can see here with males, when you're comparing from week to week, males' scores from week to week didn't seem to differ that much. All of these values are over 0.05, really except for maybe one comparison here between week 1 and week 2. So if we look at week 1 and week 2, they had a small bump in their anxiety scores in week 2, evidenced by a higher score in week 2 than in week 1. All right. So for the most part, males' scores seem to stay consistent over the 4 weeks. Now let's look at females. So females do have more significant differences when we're comparing. So let's see, from week 1 to week 2, we see a significant decrease. So 8 to 4, yep, so that's a pretty significant decrease. And then comparing week 1 to 3 and 4 as well, it looks like week 3 is lower than week 1, and week 4 is lower than week 1 as well. If we look at more comparisons, they're all pretty much just comparing week 1 to separate weeks here, and these last few weeks aren't that much different. So really, they were more anxious during week 1, and then 2, 3, and 4, they hovered at about statistically the same level of anxiety. All right. So this is how you would pull out patterns of information from probing, what's called probing this interaction. You are able to dig in a little bit deeper by seeing how these different groups differ based on these factors. All right, so this again is a mixed model Anova. A lot of this information can get really complicated and tedious, so you want to make sure that you're reading all of the boxes step by step, piece by piece, and that you're not going too fast to where you might miss something.